So we're going to learn about electrolysis today. Have a look at the reactivity series again. And there's a question on there, why can't carbon be used to extract aluminium in the same way that carbon is used to extract iron from its ore? And if we look at the reactivity series, we can see that the answer is because carbon is below aluminium on the reactivity series. It is not reactive enough to displace aluminium from its ore. So there are some metals up here that we're going to need some other method to extract from their ores because carbon's simply not reactive enough. And one of those methods is electrolysis. And electrolysis is quite a big and quite a technical word, but actually with words like this, if we split them in half, sometimes it's easier to understand them. So the electrode part of electrolysis means literally electricity, it means we're using electricity, and the lysis part means splitting. And if in biology or any other science you happen to come across words that end in the sound lysis, it's pretty much always something to do with splitting. So it might be, for example, in this case, splitting compounds up into smaller things. So electrolysis means splitting stuff up using electricity. Right, how does it work? Okay, this is how it works. Metals always form compounds with non-metals. So for example, iron is a metal and it forms a compound with oxygen that we call iron oxide. Copper is a metal and it forms a compound with sulphate, which contains oxygen and sulphur, both of which are non-metals. And when metals form compounds with non-metals, they do that using things called ionic bonds. And we shall learn a little bit more about ionic bonds later on. And when metals and non-metals form these ionic bonds, the metals always form positively charged ions. So this means they have a positive electrical charge. Always. Metals, positive. Non-metals, on the other hand, always form negatively charged ions. They always have a negative charge. Now, the only other thing you need to remember in order to understand electrolysis is opposites attract. So sometimes we use that phrase with reference to humans. Sometimes we use that phrase with reference to magnets. So the North and South Pole attract each other, whereas the North and North Pole they repel. It's also the case with electrical charges. Opposite charges will attract each other. So, if we were to take a metal compound, like this one here, I've got some copper sulphate, and we've got it in liquid form, so the copper sulphate has been dissolved. So in there we've got some positively charged copper ions and some negatively charged sulphate ions, and we want to split them up so that we can get the copper, so we can extract the copper. So what we can do is we can put it, there's two different ways. We've got a beaker on the board, so we could fill a beaker with some copper sulphate solution, and then we could set up a circuit. But the circuit is not complete. We can see two electrodes, what are called electrodes here, and they're not touching. So in fact, the only way that the current can flow around this circuit is if it flows through the copper sulphate solution. And the way this happens is we've got a positive electrode. And so the positive electrode will attract the negatively charged ions in that solution, the sulphate ions. And we've also got a negative electrode. And the negative electrode will attract the positively charged copper ions. So this means when we switch on our circuit, we should have a solution. You won't be able to see the ions, right? But we should have a situation in the solution where the copper will start to be attracted over onto this side, and the copper will stick. The copper ions will stick to this electrode, and the sulphate ions will move in the opposite direction. And if we leave that switched on for a little while, and then take the electrodes out, we should find that the negative electrode is covered in a nice thin layer of copper. We have extracted the copper by splitting copper sulphate using electricity. And even if you don't know when you set the experiment up which the negative electrode is, you will do after the experiment, because of course it will be the one that's got the copper on it. Ha! Okay.